Hi, this is the video for Year 12 Maths. I'm looking at mechanics and I'm working towards exercise 11D. This is where we're using integration in variable acceleration expressions. Now, remember that integration is the opposite to differentiation. So integration is where you increase the power. So the integral of ax to the m is going to be ax to the m plus 1 over m plus 1. You increase the power, divide by the new power, and don't forget the plus c. We already know that displacement differentiates to velocity and velocity differentiates to acceleration. Well, if I go the other way, if I integrate my acceleration, I get my velocity, and if I integrate my velocity, I get my displacement. Remember, sometimes displacement is, they call it x, sometimes they call it x. Sorry, sometimes they call it s, sometimes they call it x. Doesn't matter. Velocity is pretty much always v, isn't it? And acceleration is pretty much always a. So example 6 says they give me, what do they give me? They give me the velocity, 6t minus t squared. I want the displacement. Well, to get from velocity to displacement, I integrate. So the displacement is the integral of the velocity. So I'm going to integrate 6t minus t squared with respect to t. Increase the power, 6t squared over 2. Increase the power, minus t cubed over 3. Not forgetting my plus c. Now I know that, so it says at time t equals 0, the particle is the point where x equals 5. Now they've told me that so that I can find my c. So t equals 0, x equals 5. I'm going to sub it in to find my c. 5 equals 6 times 0 squared over 2 is 0. 0 cubed over 3 is 0. So c must be 5. So x is 3t squared minus t cubed over 3 plus 5. That's part A done. When t equals 6, that's part A. When t equals 6, x is 3 times 6 squared minus 6 cubed over 3 plus 5, which is 41 meters. Well, I've gone from 5 meters to 41 meters, and so the distance I've travelled is 36 meters. That's example 6 done. Okay, before we look at example 7, just a reminder that we can integrate with limits. And what we do is we integrate sub in b, sub in a, subtract one from the other. What that actually tells us, and we didn't look at this when we did the integration, so I'm going to tell you now, what that actually tells us is the area under the graph between a and b. Now we know that the area under a velocity graph, well, that's the integral of velocity, so that's displacement. So if I get the area under a velocity graph between 2 points, that's displacement. So the integral of v between t equals a and t equals b actually gives me the displacement between those two times. Oh, my pen's running out. I'm going to have to go to blue. So example B wants the example 7, wants the distance travelled between two values of t. So it tells me v is 5 minus 3t squared. So I'm going to integrate to get the displacement. The integral of v, which of course is 5t minus 3t cubed over 3 plus c. Let's just simplify that. Now, because I'm going between two values, I'm going for s between t equals 2 and t equals 3. Remember, when we have the limits, we don't actually care what the c is because I subtract one from the other and those c's cancel out. So I'm going to go between 2 and 3. I'm integrating v, and I don't actually care what the c is. Remember, the process is square brackets for the integration. Still got my limits there. Then I sub in. So 5 times 3 minus 2 cubed, 15 minus 8. Sub in my 2, 5 times 2. Oh, I've just done that wrongly, haven't I? 5 times 3 minus 3 cubed, 15 minus 27 minus 5 times 2 minus 2 cubed, and I end up with minus 14. Now remember, we can have negative displacement. It just means travelled in the negative direction. The question actually asks for the distance, so I would say distance is 14 meters. So the key learning points here: area under a velocity graph is displacement, and when I'm using limits, I don't actually need to find c. Okay, that will do us, I think, for exercise 11D. Let me know if I can do anything to help, and I'll see you for the next one.